This is evidence that a load test was performed with DDR5-9000. If you want to cheat by editing the video, you can, but I'll show it as evidence. Hello, I'm Aretha. It was very difficult, but I managed to complete it. This time, I was able to stabilize it at DDR5-9000, so this is a video where I'll talk about it while running benchmarks. By the way, I used B3 for more than 12 hours, which I don't know how to read, even though it is stable. I just tested ANTA 777 Absolute for more than 12 hours. Please note that we have not done anything more harsh than that. I will also talk about latency as a system, which I couldn't talk about in the previous video. I hope you can watch it until the end. Well, let me start by explaining the environment. There are no changes from the environment I explained previously. The CPU is AMD Ryzen 7 8700G. The motherboard is ASRock B650M HDV, M.2 BIOS 2.08. The memory is KLEVV Verify 80-76B360G. The official supported memory specs are 7600 megatransfers per second with XMP. The latency is 36464686. Expo is not supported. Other than this, the contents are as shown. Now I will publish the DDR5-9000 settings. Of course, if you simply copy this setting as is, it will most likely not work. Assuming you have the CPU, motherboard, and memory all set, I think it will post, but I don't think it will operate stably. Please keep this in mind when viewing. I think those who know it will understand. It has a fairly loose setting. First, gear down mode is enabled. If you have lost interest, please close your browser. In my home environment, no matter how hard I tried, it would not start with disabled. Some of the timing is quite loose. Well, there is simply not enough voltage. I think the resistance value is also not optimal. I think the RTT is adjusted to a reasonable extent. If the RTT is out of sync, the memory will not work properly. CL gets worse by about 4 and RCD gets worse by about 5. This is easy to check. And by adjusting the memory timing with the same memory at a lower frequency, such as 6400 or 7600, and comparing it to the actual time, you can determine whether it is roughly correct. In this case, we were checking it by comparing it to the actual time of the 7600. If it is extremely off, the actual time setting that should pass will not pass. Don't be overconfident as it may not pass simply because the memory is reaching its frequency limit. I'm not very confident about ODT and drive strength. I feel like if this area could be optimized it would be a little better. If you want to achieve perfect optimization, you will need an oscilloscope, so this is the limit. I'm limiting the voltage to VDD 1.53 volts, so I think this is the limit. If you ask me if I said it was up to 1.52, I agree. No matter how hard I tried, it didn't seem to be stable, so please forgive me. I've confirmed that it works up to 1.7 volts, and although the various timings are shortened according to the voltage, it doesn't scale very well, and it will throw errors specific to high voltages. My impression was that if you configure it properly, it might be possible to use it up to about 1.67 volts. If you want to try it, do so at your own risk. In this range, it reacts very sensitively to voltage and various resistances. If you go even a little bit off the sweet spot, it will suddenly start throwing out a lot of errors. So I think it's very important to guess what's wrong from the errors that are being thrown. Well, that's very difficult. Also, there are quite a few training failures. At 6400 or 7600, training failures are rare. At 9000, training failures occur about 20% of the time. So if you have context restore turned on, you'll be in big trouble. After doing all this, I realized that 7600 was easy. I think it was good that I was able to stabilize it. There's no point in talking about complicated things, so let's move on to the benchmarks. This benchmark is the same as the last one. Final Fantasy XIV Downtrail Benchmark VR 1.1 Desktop Standard Full HD. Final Fantasy XV Benchmark Low Quality Full HD. BlueprotocolBenchmark Low Quality Full HD. And 3D Mark. Timespy Firestrike Nightraid Steelnomadlite. I'll also include the data from the last time for comparison. So, even though the timing is loose, let's see the power of DDR5-9000. This is the Final Fantasy XIV Downtrail Benchmark VR 1.1. Look at it. It's definitely showing the effect of 9000. My score has improved. Yay! I spent hundreds of hours on this. I'm sure a skilled person could put together the settings in a shorter time. But I couldn't. But I'm sure this experience will be useful in the future. I might do something similar again if I feel like it. For some reason, it seems like the score is not growing very well, right? Compared to the 7600, the 9000 should have a considerable advantage in terms of bandwidth. There's something ominous in the air. This was just the beginning of the tragedy that was about to begin. This is the Final Fantasy XV benchmark. This is where the tragedy began. The score has dropped. How did this happen? The reason why I decided to aim for 9000 this time is that actually, apart from the KLEVV I'm using this time, I have acquired some nice memory. I will make a video about that later. I was aiming for DDR5-9000 with that memory, but I just couldn't get past the 9800 barrier. The memory voltage is about 1.45 volts, so it's clear that I'm not at the limit at all. I thought that I was stuck on some kind of limitation other than the memory, so I sacrificed KLEVV, which was the best memory I had at the time, and tried to find out. This is the Blue Protocol benchmark. Don't give up yet. You might improve here. Yes, I knew that. This will probably be the last time I use this benchmark. Thank you for everything. The score is steadily decreasing. The reason why I'm investigating with KLEVV is that I sometimes apply unreasonable voltage for various tests, even for a short time, and I thought it would be a waste to use up new memory like that, so I'm using KLEVV, which was demoted from ACE. By tinkering with this memory, I've discovered the strong points of this memory that I didn't know before, and I've also gained a deeper understanding of my environment, so I'm glad I did it. From here it will be 3D Mark. First of all, it's Timespy. As for the score, it goes without saying. The motherboard I'm using this time is B650MHDV M.2. Considering the price, this performance is exceptional. High-end for true overclocking. Although there are some aspects that are inferior to Tachyon, Gene, and Apex. It's amazing what you can do for this price. However, of course there are limits to what can be set in the BIOS. After all, it is inferior to the motherboard group mentioned earlier. In terms of memory, the only Nitro-related settings are burst range. With the above motherboard, you can also use train op, skew, and DFE TAC. You can't change that part manually. However, it is still a motherboard that can aim for 9000 to 10000. I think the settings are appropriate. Next is Firestrike. Yes, of course I didn't break 10,000 points. By the way, I included a revenge version at the end of the video. If I just wanted to break through, I thought I could reach it by adjusting it to 8000, but 8000 isn't that rare, so I aimed for 9000. That's more fun for everyone, right? It's not interesting to use overclocked memory, set it up in XMP or Expo, and say it worked. It's a mediocre result that anyone can achieve. There's no dream there. Next is Nightraid. When I started messing around with KLEVV, I didn't care if it broke, so I was testing it by pushing in a lot of voltages, and I was able to get to the BIOS at 10,400 without any problems. So I thought, oh, this thing is better than I thought? And while I was testing it, I fiddled around with it, and it seemed like I could make it stable at 9000. I thought it would be interesting if I could make it stable at 9000, so I decided to make this video. Actually, I was just going to go for 8400 or so. Lastly is Steelnomadlite. Of course, there is no way that DDR5-9000 will become stable easily. It has been a series of hardships. If various voltages are out of the sweet spot, a large amount of errors will occur immediately. Training can fail. There were times when I would get a lot of errors even though I didn't change any settings. In the midst of this, we are conducting stability tests. Is the cause of the error due to training failure or due to timing adjustment? Judgment is required each time. Of course, there is no way you can make an accurate judgment every time. I sometimes had to redo the settings many times. Therefore, each timing may be able to be further shortened. Well, the benchmark scores are now all out. The results are miserable. It's easy to think that if the frequency increases in theory, the performance will increase, but in reality, this isn't always the case. The memory performance is not being fully utilized due to the various settings that were loosened to stabilize the 9000. There were no videos testing the performance with the 9000, so I gave it a try, and it was a good learning experience. By the way, the benchmark using iGPU was 9200 for me. Above 9400, it seems that something other than memory is reaching its limit. It suddenly restarts without any warning. If the area exceeds this, both the OS and BIOS will be damaged. Verification is very difficult. In terms of behavior, I feel like it's at the limit of Infinity Fabric, but I don't have any proof. This can be avoided by installing a PCIe graphics board. With the exception of one person, everyone who has recorded DDR5-9000 or higher has a graphics card plugged in, so I don't think this is just happening to me. I guess we'll just have to wait for the next generation. I think the world will change again when CUDIMM and Cam 2 become realistic options. I hope I can have fun again in that environment. Finally, let's talk about system latency. I feel like not many people in Japan are concerned about it, but many people around the world are. What is famous is the memory latency measured by AIDA64. There are some difficulties in this measurement. There are many ways to achieve low latency. Turn off SVT, power down mode and context restore. You will have to go through various troublesome steps such as starting up in safe mode. Well, if you follow these steps, you will get accurate numbers. I use it for everyday purposes where it would be a problem without SVT. I usually don't turn off context restore because it slows down the startup process. Therefore, if you measure it normally, you will get disappointing numbers. Now, let's show you the data. I also measured it with AIDA, but this time I will talk about the microbenchmark data. This is a graph that measured the latency. The comparison is with the original 5600, and the tweaked 6400, 7600, 8400, and 9000. Something is a little strange around 1024. This seems to be a quirk of the 8700G. The measurement results are inconsistent and unstable every time. Well, this area has nothing to do with memory, so please ignore it. The overall diagram looks like this, but it's hard to understand, so I'll enlarge the part on the right. This is an area that is mainly affected by memory. As expected, 5600, which is not doing anything, has a horrible latency. It might be worse with JEDEC compliant standard settings. No major differences are observed for other frequencies. The best result was 9000. As for latency, it gets worse depending on the memory controller ratio. So I thought it would be worse for the 7600, but the difference is smaller than I thought. It's not a big difference, but it's slightly worse. But this is the 7600. And unless you compare it with a 1:1 6400 and a 1:2 6600, you might not see a clear difference. If you're aiming to reduce latency, I think it's more important to adjust the timing than the frequency. Of course, there are good and bad points in terms of frequency, so if you value latency above all else, you should pay attention to it, but if you're looking at overall performance, I don't think you need to worry too much about it. In terms of latency, the 9000 is excellent, but the results in various benchmarks are disappointing, so I don't recommend it. Finally, I will also post the measurement results with AIDA64. If you're in your early 50s, I feel like it's quite short. This number was calculated without making any changes to the settings that produce the short latency unique to IDA. So numerically it's not a big deal. Still, the 5600, which does nothing, is different in terms of other things. The conclusion is that people who are concerned about latency should set the memory timing properly. By the way, I made various settings changes out of curiosity. I measured the memory latency of IDA with the tweaked 8400. It came out to 52.3 nanoseconds. This is just a result with a setting of 1.55 volts. I think it's excellent considering the low voltage. Probably, but if you adjust it properly with 9000, I think you can get 51 nanoseconds. In short, the first thing to do is to properly adjust the latency. And I don't think you need to worry too much about frequency unless you're a latency nerd. Well, 9000 various verifications have been completed. As for my impressions, after all, higher frequencies are not necessarily better. I understand why someone said that anything above 8200 is a hobby. Maybe he was verified. However, this result was confirmed in our environment, so results may not be the same in all environments. I cannot deny the possibility that my score would have improved if I used more durable memory. In fact, there are many people who are running it with a higher voltage and properly adjusted sub-settings. Their scores have improved steadily, so it's not simply a matter of 9000 being no good. Considering the information available from various sources, it seems that for practical use, you'll need 1.6 volts or more. Well, if you want to squeeze out the performance to the limit, I guess it's important to find out where each part works most efficiently. To put it simply, you shouldn't try to stably use DDR5-9000 on a regular basis. However, if you are a strong fighter who is confident in your skills, please give it a try. I did it too, right? It's fun. To be honest, I think it's wise to use it at around 8000 and adjust the timing. Well, since this is how it turned out, I'm planning on making another video about memory, although it wasn't originally planned. What was wrong with DDR5-9000? The reason why I have data on the tweaked 8400, which I never mentioned, is because after the stabilization work on the 9000 was finished, I tweaked it with the 8400 and checked the degree of impact of various timings. At that time, I also took the opportunity to get revenge on Firestrike. Simply saying that DDR5-9000 was no good means that literally nothing has been achieved. This will be a video that talks about it while looking at the data that verified it. The data itself has been collected, so I think it will be available soon. In other words, I already know why DDR5-9000 failed, and I'm making this video. So I would like to apologize. I'm sorry for having to deal with this farce. The next video is the final version. Please take a look if you like. Finally, I'll also include an extra image of Firestrike Revenge. I tweaked it to 8400 and achieved over 10,000. To be honest, it was more difficult than I thought. Thank you for watching this time.